SPS, where I am working as a facilitator. Here, some of the scientific learning materials I have prepared is only to do with the children. It is not the teacher who is going to do. It is a low-cost materials are shown to the students. Here, the first one, the X-ray tube I am saying. The X-ray tube, we are usually very costly. It is very not possible to have a small schools like that. So we prepared this X-ray tube with this. Just a round bottom flask and the two test tubes. Round bottom flask, the neck has to be cut and the two test tubes has to be joined with a quick fix. At the same time, you have to make that the two holes at the bottom of these two test tubes, and you have to insert a glass tube. Along with that, you have to insert the two terminals of the wires. At the end of the wire tube, you have to put the LED bulb. And this side, we have to make it as a dummy one, and only just at this point, you have to join with this glass tube. And inside the metal, what you are going to fix with this a small glass tube, and a wooden block is cut into a piece with an angle of 45 degrees, and you stick a mirror to reflect that light, and the connections as made as shown in this model with a switch and a battery and this transformer. And exactly the thing is going on there is that it is a low pressure tube and it is producing the high voltage. When you put on the switch, what happens? The high voltage current is passing through the cathode. At the cathode, it produces the fast moving electrons. These fast moving electrons hit the metallic plate with a high melting point, which is a high melting point, and produces the X-rays. This is how you can see that the X-ray is producing. At the side, you can see that light. Thank you. And it is the model of an extraction of petroleum. This is the plastic bottle and the lid and the pen outer we have made use here. Here we are finding that the two concentric pipes. The concentric pipes means one inside the other. So you can take these two pipes here. One is the refill, and you make a small hole and insert inside. It is the one which is inlet of the compressed air, and the other one is the outlet of the petroleum. If you blow the air from this inside the inlet tube, the petroleum will come out of this one. Just I will show how the petrol will come out. These things are made of only the low-cost materials. Now we come to the convergent rays and the divergent rays. In this convergent rays and the divergent rays, it is difficult to get the rays converging and the diverging in the laboratory concave mirrors. But here, you take the face of the X-ray and make that stick to the piece of these plane mirrors with a different gap of 1 centimeter there. And there, you just hold it like this, you will get the convergent rays. Focusing, sir. And the point where it is converging, that point we call it as a principal focus. And if you turn it back, you are going to get the divergent rays. The divergent rays, if you are going to produce it backside, you will get the point, we call it as the principal focus for the convex mirror. The principal focus always in the back of the mirror in the convex mirrors. Then comes to the persistence of vision. What is persistence of vision? the persistence of fusion. Now you see, this is a bird and this is a cage. In this bird, I will bring that bird into the cage. How to bring that one? Just I will put some mantras. Okay? Now you will see that the bird in the cage. How this bird has come into the cage? It is not because of my mantra. It is because of that persistence of vision. The persistence of vision is that the picture what we have seen is retained for 1/10 of a second. At the same, now you are seeing the bird picture. At the same time you are seeing the cage. So when they are seeing one over the other, they are overlapping. So you are able to see that both the pictures. That's why we say that there is a persistence of vision. And comes to that the motion. Then we are having the inertia. What is inertia? Inertia is that a body continues to be in the same state where until and unless an external force is acted upon it. So now the cup and the bead are in resting position. Now I am applying some force, then what happens? It is going to get the motion. So what happens? So now it is moved. Both the cup as well as the bead are moved. So what happened? The bead moved, cup moved a little and the bead moved continuously. Why? What is the reason for that? This cup is pulling by the thread and it is stopped there. The external force is acting upon this cup, but whereas the bead is continues to move. Suppose if that no other force is acting on it, it continues to move like that only. But it falls down. Why it is not fall down? Because of the other forces, the gravitational pull or the air force, all these are acting on that bead, so it has been come to the ground. Now comes to that the Newton's third law of motion. The Newton's third law of motion says that for every action there is an equal and opposite. To show that it is just the straw we have made use here. The straw is that the juice straw. Here, just you see the motion of this straw. I am blowing the air here. The air comes out of this mouth and it pushing the straw in the opposite direction. So I change the direction and now you see the motion of this straw. Now also it is in the opposite direction. So the one part of that we are able to explain. Now the second part is that it is the equal. How to say that equal? For that you blow the air slowly, faster, faster and fast. Then what happens you see? So this shows that when you blow slowly, the air comes out slowly, so it pushes very little. When it is more, then it is more oscillation. And if it is more, then it is going to completely rotate. So this shows it is equal. And comes to the matter, that is the gases, liquids and the solids. Here we are saying that the gases can be compressed. So for that we are using the syringe. So in the syringe you just pull inside. Then what will happen? The air enter inside. So to hold it tightly, I am going to cut this tip here. Hold it tightly and try to press it. So what happens? It is compressed. Why it is coming back? It is affecting on that once again. So it can be compressed. That we can show. At the same time, you take the liquids into the thing. Now I take the water in the syringe. Now it is completely the liquid. So try to compress it. So here once again it is not able to compress. This application we have to tell. Where is the application? That is, we are using it in the hydraulic jogs, in the service stations, and also in the excavators, and also in the dumping of the loads with the tractors. Now it is a service station model. You see, just rise. Now after servicing, he has to pull it down back once again. Here I made use the water, but in the service stations and other things, the hydraulic jogs, they are made use of the oils. This is done very simply with these two. One is at the syringe is at the other end, and one is at this end. One syringe completely filled with the water, and the pipe is also has to completely fill with the water. The rest of this thing has to be completely squeezed. Now you just see the movement of this one. You'll see how it is going up and down. And usually in our schools, to bring the light into the classroom, that is especially the sunlight, very difficult. We are keeping the mirrors on the sunset, and you will see that when we are adjusting it and when we are coming to put the stones and other things, it is going to change its direction. To avoid the change of direction and other things, just I made use of this rear view mirror, which is the broken one. And here I replace with a plain mirror, and I put it into a stand, and you keep it in the sunshade, and then you can turn to any direction and you can get the light to required place. So after that lesson, you have to do the lesson of the movement of the sun, moon and the earth, and also the days and the nights occurring, and the motion of this moon along with the sun, earth, all these things we have to teach. So this movement, so here the movement of the earth along with the moon we can give, and at the same time you can explain the eclipses also. Now this is the lunar eclipse, and when it is near, it is a solar eclipse. After taking this lesson, you have to take it out or you can remove it. Now with these pieces of this electric pipes and the elbows, we can frame our required things there. Frames on the stands like that. So like this we can prepare this. So instead of that, we have already prepared one thing, this stand. This stand is made used to say that conversion of energy. The conversion of energy is that now I am turning this because of the position of height, it is got the potential energy. When I leave this, what happens? It is converted into the kinetic energy, and once again that kinetic energy is turned into the potential kinetic, and it is going to rest. So soon after this lesson, we are taught you can remove this. And we can teach the simple pendulum. The laws of simple pendulum also you can teach. And through the simple, laws of simple pendulum, we have to make use of the different size. I got this one. So you can vary the size of the bow, or you can vary the length of the simple pendulum. And you can prove that the three laws. If a teacher make up his mind, he can do the things wonderfully, and it is no need to wait for the any government facilities. He can do on his own. Thank you.
Actually.